Good morning, everybody. So we've been learning about polygons, right? And a polygon is basically just any shape with three sides or more. Uh, Polygons also have straight sides, right? So no circles. It's got to be a closed shape, so no open sides. There shouldn't be any intersecting lines, right? So no lines that are crossing over each other and no curves, right? And we name our polygon based on the number of sides, right? A triangle has three sides. A pentagon has five sides. A heptagon has seven sides, right? Now we also know that we can classify polygons as either a regular polygon or a not regular polygon, right? Regular polygons, all the sides, all the angles are the same. And a not regular polygon, sides are different lengths, the angles might be different, okay? So regular versus not regular, and we know a polygon is just any shape, any closed shape with three or more lines, right? So we also learned about angles the other day, right? And we learned about obtuse, acute, and right angles. Remember, an obtuse angle is any angle greater than 90 degrees. An acute angle is any angle less than 90 degrees. Remember, it's a cute little angle, and this is a big obtuse or obese angle. Big angle, small angle, and then remember, a right angle is any angle that is exactly 90 degrees, right? Straight up and down and straight to the side. Okay? So today, though, we're going to be learning about a certain type of polygon called a triangle. All right, and so here's a bunch of triangles. There's a whole variety of triangles. We can have triangles that are really long and skinny. We can have triangles that are a little wider and fatter. This one almost looks like a regular polygon, right? It looks like all the sides are exactly the same length, whereas this one, this side, is much longer than this side. And we can have other polygons where it looks like, maybe all the angles are exactly the same, or other polygons where, this angle is much smaller than this angle. All right, so lots of different triangles out there. So today what we're going to do is we're going to try to classify these triangles, right? And so we could put all of them in one of three groups, all right? So there are two ways to classify triangles. We can classify them by the length of their sides. We can also classify them by the measure of their angle. And we're actually going to use both of these ways to classify a triangle today. First, we're going to look at the sides, then we're going to look at the angles, and we're going to give each triangle two names, right, based on their side and their angle. So let's look at the sides first. So we got three different triangles. We have an equilateral triangle, an isosceles triangle, and a scalene triangle. So let's look at the triangle next to them. So an equilateral triangle has blank congruent sides. And remember, congruent just means exactly the same, right? So let's see. We've got a 3-inch side, a 3-inch side, and a 3-inch side. So all the sides are the same, right? So how many sides does an equilateral, or sorry, so yeah, how many sides does an equilateral triangle have? Well, an equilateral triangle has three congruent sides, right? So if all three sides are the same, it's an equilateral triangle. And look at the prefix there. Equal, right? Equal means they're all the same. So an equilateral triangle, all the sides are the same. That's an easy one to remember. The next two are not as easy. So let's see. Now we have an isosceles triangle. Isosceles. So an isosceles triangle has blank congruent sides. So congruent means equal. So let's look. So we got 3 inches and 3 inches. Those are equal, right? And look, the whoever made this triangle even made little markings here to show that these are equal. So 3 inches and 3 inches. But this side's 2 inches long. So does an isosceles triangle have three congruent sides like an equilateral triangle? No. How many congruent sides does an isosceles triangle? Well, it's got one, two congruent sides. So three congruent sides is an equilateral triangle. Two congruent sides is an isosceles triangle. And now what do you think is going to be the deal for a scalene triangle? Let's see. A scalene triangle has blank congruent sides. Let's look. 5 inches, 4 inches, 3 inches. Are any of these sides congruent? No, of course not, right? None of them are congruent. So a scalene triangle has zero congruent sides, okay? So you've either got all sides the same, two sides the same, or no sides the same, all right? Equilateral, isosceles, and scalene. So once we've given it its side name, now we have to give it its angle name, right? Every triangle has two names. based on the length of its sides, and now based on the measure of their angle, right? So we could have an equilateral triangle, but then we're going to talk about whether it's a right triangle, an acute triangle, or an obtuse triangle, right? And remember, in a right triangle has 90 degrees. Acute means less than 90, and obtuse means more than 90. So let's look at this. So a right triangle has one 90-degree, or what's another name for that? A right angle, right? So right triangle has at least one 90-degree angle, right? And there it is. So I don't care about these other two angles, to be honest. If I see that right angle, I know it's a right triangle. That's it, right? There's no negotiation about it. Doesn't matter if these are acute angles. If I see that right angle, I know it's a right triangle, okay? How about an acute triangle? Well, acute means less than 90, right? Less than 90 degrees. So an acute triangle has three blank angles. Well, let's look at these angles. We have 30 degrees, that's less than 90, that's acute. We got 75 degrees and 75 degrees, both of which are acute. So all three angles in an acute triangle are acute, and that kind of makes sense, right? So an acute triangle has three acute angles, right? I don't see any right angles, so it's not a right triangle. It is an acute triangle because it's got three acute angles. All right, and last but not least, an obtuse triangle. I'm sure you can guess this one's probably got an obtuse angle, right? Something more than 90 degrees. So let's see. An obtuse triangle has one blank angle. Well, let's see. I got 18 degrees. That's acute. I've got 32 degrees, which is also acute. But look here, I have a 130-degree angle. That's an obtuse angle, right? So how many obtuse angles does an obtuse triangle have? Looks like just one, right? An obtuse triangle has one obtuse angle, right? An obtuse triangle is one obtuse angle. So a right triangle has one right angle. An acute triangle has all three acute angles. And an obtuse angle has one obtuse angle, okay? So we are going to be naming these triangles based on their sides and their angles. We're going to give every triangle two names. So let's look at some triangles here. So here I've got 6 triangles. Let's try to name them based on their sides and their angles. So let's look at this first one. Let's start with the sides. So I've got 9, 15, and 14. Are any of these the same? No, they're all different. So if we have 3 different sides, what's that called? That's a scalene triangle. It's got 0 congruent sides. So I know that this triangle is scalene because all the sides have different measures. So that's its side name. What about its angle name? What do I see about these angles? Well, I got 66 degrees, 78 degrees, 36 degrees. What do all these angles have in common? Well, first of all, is there any right angles? No. Are there any obtuse angles? No. In fact, they're all acute. So that means this is a scalene acute triangle. Okay, I give it 2 names. Here's its line length name. Here's its angle name, scalene acute. All right. All right. How about this one down here? Now there's no numbers, but I do have markings, right? So what do these markings tell me? I've got one line here and one line here. So that means that these 2 lines are equal, right? But this one's different. What's it called when we have 2 congruent sides? Let's look back at the previous page. When we have 2 congruent sides, that's an isosceles triangle, right? So that means this one is how do you spell isosceles? I-S-O-S-C-E-L-E-S. Oops. C-L-E. So this is an isosceles triangle. That's its length name. What about its angle name? So let's see. These are 2 small angles. 2 small angles. Is that obtuse? It might be obtuse. It kind of looks obtuse. It's not a right angle, right? Because a right angle, we would have that mark. It almost looks a little bigger. So this has one obtuse angle. So I'm going to say this is an isosceles obtuse triangle, right? It's isosceles because it's got 2 congruent sides. It's obtuse because it has one obtuse angle. All right. Let's do 2 more together, and then I'll have you do the last 2 on your own. All right, how about this one up top? So first, the side length. I got 5 inches, 5 inches, 5 inches. So what type of triangle is this? They're all equal, right? So that means we have an equa. Is it equi or equa? Equi. We have an equilateral triangle because all sides, equilateral, all sides are equal. Now let's look at the angles. All the angles look the same. They all look less than 90 degrees. There are no obtuse angles. They all look acute, don't they? So that means this is an equilateral, acute triangle. All right, one more, and then you got the last two on your own. How about this one? Let's see, 1 line, 3 lines, 2 lines. So none of these are the same, right? What's that called? That's a scalene triangle when no lines are congruent. And now let's look at the angles. So, what do we see here? This is a right angle, right? So that means it's a scalene right triangle. All right. I would like you to pause the video and let's see if you can do these last two. That's going to be your problem of the day. You should open the note sheet if you haven't already opened it. And let's see if you can do these last two on your own. Name them based on their side and their angle and bring that as your problem of the day to your teacher center. All right. Open up the notes. Try those last two. We'll go over them as a group. Go ahead, guys.